Here we have AP calculus AB problem. Okay, let's go to the information. The graph of f consists of line segments and a semicircle as shown in the figure. Evaluate each definite integral by using geometric formulas. Okay, now let me go to the definite integral in part A, that is integral 0 to 2 f of x dx. So here the lower limit of x is 0, the upper limit of x is 2. So in the given graph, we have x equals to 0 here and x equals to 2 over here. So from 0 to 2, we find 1/4 of a circle. So because the question says the graph of f consists of line segments and semicircles, so here we have semicircle. So in this semicircle, we have from x is equal to 0 to 2, we have half of the semicircle. Half of the semicircle is just 1/4 of the circle. Okay, now to get the area of this region, we can use geometric formulas according to the instruction we have over here. And also we can notice one more thing, from x is equal to 0 to 2, the area of the region is below the x-axis. So the area we get for this one has to be negative. So whenever we have the area below the x-axis, it has to be negative. And now to get the area of this region, that is 1/4 of the circle, we can use the formula. So the required area equals to 1/4 of the area of the circle. The formula to find area of the circle is pi r square. So 1/4 times pi times. So here this r represents the radius of the circle. So clearly the radius of the circle is 2 units. So we can plug in 2 for this r. Then 1/4 times pi times the evaluation of this 2 square is 4. So this 4 will cancel out. I'm getting just pi. So the area of 1/4 of the circle, I mean the area of this region is pi. Since this region is found below the x-axis, it has to be negative. So the evaluation of the definite integral in part A is negative pi. Okay, now let's evaluate the definite integral in part B. In part B, we have integral 2 to 6 f of x dx. So now let's go to the graph and identify the region we have from x equals to 2 to 6. So here we have x equals to 2, here we have x equals to 6. From 2 to 6, the area covered by the graph of f of x is the triangle we have over here. And we have the area of this region above the x-axis. So the result of the evaluation of this definite integral will be positive because we find the area above the x-axis. And we can use geometric formula to get area of this region. So to get area of a triangle, so the formula is, let me write the formula over here. So that is base times height divided by 2. So the base of the triangle is from 2 to 6, there is 1, 2, 3, 4 units. So the base of the triangle is 4 units and the height of the triangle is 2 units. So let's plug in 4 for base and the 2 for height. So 4 times 2 over 2, this 2 will cancel. I'm getting, so the area of 4. So the evaluation of the definite integral 2 to 6 f of x dx equals to 4. Okay, now let's evaluate the definite integral in part C. In part C, we have the definite integral, that is the integral negative 4 to 2 f of x dx. So the starting value of x is negative 4, it's over here. The ending value of x is 2. So we have two different regions. So that is from negative 4 to negative 2, we have a triangle over here. And from negative 2 to positive 2, we have a semicircle over here. And both the regions are found below the x-axis. Okay, so we have to find the area of each region and we have to take negative sign for each region and we have to add the two areas to get evaluation of this definite integral from x equals to negative 4 to 2. Okay, so let's find the area. So let me take a negative sign to get area of this particular region. Since this region, I mean this area of this triangle is below the x-axis, I'm taking negative sign over here. So again, we can use a formula to find area of a rectangle, that is base times height. So the base of the triangle is 2 units, that is from negative 2 to negative 4. And the height of the triangle is given by just 1 unit because this point is corresponding to negative 1 on the y-axis over here. So the base of the triangle is, the base of this triangle is 2 and the height of the triangle is 1. So we have 2 times 1 base times height divided by 2, and again I'm taking negative sign for this region because this region is also found below the x-axis. Since we have a semicircle over here, we can take 1 over 2 times the area of the circle pi r square. So here r is the radius of the circle is 2 units. We can plug in 2 for r over here. So this 2 will cancel. I'm getting negative 1, negative 1 over 2 times pi times the 2 square is 4. 2 goes into 2 1 times, so 2 goes into 4 2 times. I'm getting negative 1, negative 2 pi. So we can factor negative sign out. So then we get negative of 1, positive 2 pi. So this is the evaluation of the definite integral in part C. Let me write the stuff over here. Negative of 1, positive 2 pi. Okay, now we can do part D. In part D, we have integral negative 4 to 6 f of x dx. Let me write this integral as it is, negative 4 to 6 f of x dx. So when I go to the given figure from x equals to negative 4 to x equals to 6, we have all the three regions are covered. So here we have x equals to negative 4 to x equals to negative 2, we have the first region. From x equals to negative 2 to x equals to positive 2, we have the second region, that is the area of the semicircle. From x equals to 2 to x equals to 6, we have a triangle. But already we got the area from x equals to negative 4 to x equals to 2 in part C. So we can split up this different integral into two parts, that is negative 4 to f of x dx, then integral 2 to 6 f of x dx. So here according to this different integral, we have to cover the area from negative 4 to 6. So this first integral covers the area from negative 4 to 2. The second one covers from 2 to 6. Okay, so for this one, we have the result in part C, that is integral negative 4 to 2 f of x dx equals to negative of 1 positive 2 pi. We can plug in this one for the first different integral. So that is negative of 1 positive 2 pi. And to get result for this different integral, we can consider the result of part B, because we have this exactly over here in part B. Already we have evaluated this different integral. Its evaluation is 4. So we can plug in 4 for this one. And now what we can do is we can distribute the negative sign to 1 and 2 pi. When I do so, I'm getting negative 1, negative 2 pi, positive 4. So when I combine this negative 1 and positive 4, I'm getting 3, negative 2 pi. So the evaluation of the definite integral in part D is 3, negative 2 pi. Okay, now we can move to part E. In part E, we have integral negative 4 to 6 absolute value of f of x dx. Okay, let me write this integral as it is. It is negative 4 to 6 absolute value of f of x dx. Okay, so here already we have discussed from x equals to negative 4 to 6, we have all the three regions. So we can split up this integral into three parts. So each part for each region. So the first part is from x equals to negative 4 to negative 2. The second part is from x equals to negative 2 to x equals to positive 2. The third part is from x equals to 2 to x equals to 6. So the first part is negative 4 to negative 2 absolute value of f of x dx. And the second part is negative 2 to positive 2 absolute value of f of x dx. And the third part is integral 2 to 6 absolute value of f of x dx. Okay, here what is the area of the first region, that is from x equals to negative 4 to negative 2. From x equals to negative 4 to negative 2, we have a triangle with the base 2 units and the height 1 unit. So base times height divided by 2, I'm getting the area as just 1. Since we have this area of this triangle below the x-axis, we consider this one as negative 1. But here we have absolute value of f of x. Since we have absolute value for the function f of x, so even if the area is found below the x-axis, we should not consider negative sign. We have to consider it as positive. So the area of the first region over here is 1. But in the previous case, we got the same area as negative 1. But in this case, we consider it as positive because we have absolute value for f of x positive. Now from negative 2 to positive 2, we have semicircle, and also we find this region and below the x-axis. Anyway, so first let's find the area of this semicircle. So that is 1/2 times pi times the radius of the semicircle is 2. So then we get to 1/2 times pi times 4. Then we get 2 pi as the area of this semicircle. So in the previous case for this semicircle, we took the area as negative 2 pi because the region is found below the x-axis. Since we have absolute value for the function f of x, so even though the region is found below the x-axis, the area has to be considered as positive, that is 2 pi. Okay, now let's get the area of the region from x equals to 2 to x equals to 6. So clearly it's a triangle. The base of the triangle is 4 units. The height of the triangle is 2 units. So the area of this triangle is base times height divided by 2. So that is 4 units. So we can take 4 for this one. So when I can add this 1 on 4, then I'm getting 5 positive 2 pi. So the evaluation of the definite integral in part E is 5 positive 2 pi. Okay, now we can move to part F. In part F, we have integral negative 4 to 6 f of x positive 2 times dx. Okay, now let me write this integral as it is. It is negative 4 to 6 f of x positive 2 times dx. Okay, now what I'm going to do is I'm going to distribute this integral to f of x and this 2. Then I'm getting integral negative 4 to 6 f of x dx positive integral negative 4 to 6 to dx. Okay, already we have evaluated this definite integral negative 4 to 6 f of x dx in part D. So its result is 3 negative 2 pi. So we can plug in this 3 negative 2 pi for this integral. So then I'm getting 3 negative 2 pi positive. So how do you have to evaluate this integral from this figure over here? So like this integral can be considered as integral negative 4 to 6 f of x dx, or even instead of f of x we can write y dx, because f of x and y, both of them are equal. So comparing this and this, so at the place of y, what do we have over here? In our integral, we have 2. So that is from this stuff what we have discussed so far, we get y equals to 2. So now we have to draw a line through the value 2 on y-axis. So then we'll be getting an horizontal line over here. Okay, now, so according to this integral, I have to find the area of the region from x equals to negative 4 to 6 between the line y equals to 2 and x-axis. X equals to negative 4 is over here. We can draw a line over here. And x equals to 6 is over here. So clearly, we are getting a rectangle. So with the length 10 units, because here we have 4 units, here we have 6 units. So the length of the rectangle is 10 units and the width of the rectangle is 2 units. So to get the area of this region, we have to get the area of this rectangle. So that is length times width, that is 10 times 2, that is 20. So the evaluation of this integral is 20. So now we can combine this positive 3 and positive 20. I'm getting positive 23, negative 2 pi. So the evaluation of the definite integral in part F is 23, negative 2 pi.